This is part 2 of ratio, rates, and proportional reasoning. We're still in the same unit. This is unit 1. But now we are using the resource, the Engage New York State modules. But you also can find this in your textbook, Chapter 5. Chapter 5, in that green textbook, Section 1 is a relation. So if you need extra help or your parents need help looking at this, we're in Chapter 5, Section 1. It looks like this, 5.1 in the book. So I'm going to go through this, and you're going to fill in notes as I go along. Example 1, pay by the ounce frozen yogurt. Oh, this is like Yummies in the Village. A new self-serve frozen yogurt store opened this summer, which it did, I think, or maybe in the spring, that sells its yogurt at a price based upon the total weight of the yogurt and its toppings. Don't get a lot of toppings, cost a lot of money. In the dish. Each member of Isabel's family weighed their dish, and this is what they found. So a 12.5 ounce yogurt dish costs $5. A 10 ounce yogurt dish costs $4. A 5 ounce yogurt dish costs $2. An 8 ounce yogurt dish costs $3.20. Does everyone pay the same cost per ounce? This is a rate. Does everyone pay the same rate? How do you know? Well, I have to take the cost and divide it by the ounce. Cost per ounce. So 12.5 cost, oh no, it would be 5 divided by 12.5. Cost per ounce. Could I do it the other way? What's 5 divided by 12.5?
2.
Oh, thank you. Cost per ounce.
Wait.
Is it? No. 5 divided by 12.5?
Oh.
5 divided by 12.5. Isn't it 0.4?
Yeah. I was looking at 12.
Tyler? Okay, so 5 divided, cost per ounce, 5 divided by 12.5. 4 divided by 10. That's also decimal point 4 tenths. 2 divided by 5. In order to know, did they each pay the same amount, you got to do each one. 2 divided by 5, decimal point 4. $3.20 cost, money always goes on the top, per ounce, 8. And yes, you get 4.4, which means 40 cents. It's not 4 cents, it's 40 cents. So, does everyone pay the same cost per ounce? The only way you can answer that is if you do all of the divisions. And the answer is yes. How do I know? I divided cost by ounces. I'm going to abbreviate, and got 40 cents each time for decimal 0.40. Okay. Isabel's brother takes an extra long time to create his dish. When he puts it on the scale, it weighs 15 ounces. If everyone pays the same rate, which we figured it out, 40 cents per ounce, how much will his dish cost? So it's 40 cents times every ounce. Well, his ounce is 15 ounces. It's the same, we figured that out. So I take 40 cents times 15 ounces. Wow, he must have a lot of toppings. And his comes out to be, this label is $6. So I could add him onto the chart here. He had a 15 ounce dish that cost $6. How did you calculate his cost? Well, I answered that. How did I calculate his cost? I took the cost per ounce, the rate, cost per ounce, and I multiplied it by the ounces to get the total cost. Cost per ounce equals the cost. Cost per ounce times the ounces equals the cost. And I got $6. Okay. What happens if you don't serve any yogurt or toppings? So if you just have an empty dish. Well, if you don't put any yogurt or toppings in it, you have 0 ounces times 40 cents, kind of a silly question, equals 0. This is the 0 property. When you multiply by 0, you get 0, right? If you don't buy any yogurt or toppings, you don't have to pay anything. Kind of a silly question, but it's there. So, I know the cost when I come up with the exact same rate every time. The same rate every time. 40 cents, 40 cents, 40 cents, 40 cents. When I come up with the same rate every time, the cost, now I'm going to fill this in, is proportional to the weight. The cost is proportional to the weight. That's the idea of proportional relationships, which is the name of this lesson. If you get the same rate every time, then those two variables, ounces and cost, and I'm calling them X and Y for a reason, you'll see in a minute, X and Y, those two variables, the cost and the weight, it could be the miles and the hours, talking about two things, the cost and the pounds, like the tomatoes question on the test. When you have two variables like that and you get the same rate every time, that's a proportional relationship. You always multiply the number of ounces. I didn't multiply the number of ounces. The opposite of dividing, I divided to get cost per ounce. Like it said here, to do this division, I divided. But I could turn this around and do the inverse of division and multiply. If you always multiply the number of ounces X, and that's why I put the X up here, by the constant 40 cents, so if I take 12 and a half and I multiply it by 40 cents, it's going to give me $5. If I take my 10 ounces of yogurt in topping and I multiply it by 40 cents, it's going to give me $4. If I take my $5, or my 5 ounces of yogurts and toppings, and I multiply it by 40 cents, it's going to give me $2. Same thing. 8 ounces of toppings and yogurt times the 40 cents will give me $3.20. So you can do this, you can figure out if this is a proportional relationship by multiplying or by finding the rate, dividing. So X they're calling the ounces, and Y is the cost. So we did 40 cents times the ounces, which is called X. I'm not going to use that time symbol because they have an X here. 40 cents times the X equals the Y, the cost. 40 cents per ounce times how many ounces you buy equals the cost that you have to pay. That's what I showed in the table when I was just multiplying this. 40 cents times 12 and a half, $5. So you take your rate times the top variable X, and it will give you the Y. I could turn this around and I could say Y is the same thing as, I could switch sides, 40 cents times the X. And that's going to become in the next few lessons, Y equals K for constant X. This is going to be a really important formula, and we're going to put it in our triangle. Y equals K times X, just like distance and speed, because we're talking about rates. Next page. Example 2, a cooking cheat sheet. In the back of a recipe book, a diagram provides easy conversions to use while cooking. Okay? What does the diagram tell us? It tells us that cups, a certain number of cups, gives us ounces. It gives us cups and it's related to ounces. OZ is the abbreviation for ounces. So I have two variables here. I have cups and ounces. Cups and ounces. I'm talking about two different things. What does the diagram tell us? It gives us cups, has a relationship with ounces. Is the number of ounces proportional to the number of cups? Is the number of ounces proportional to the number of cups? How do you know? I'm going to do the multiply way. I'm going to multiply. I know that 1 times 8 will give me 8. 2 times 8, hey, it's working, equals 16. 1.5 times 8, yes, you can check it on your calculator, is 12. I know 0 times 8, or 0 times anything, is going to give me 0. 1/2 times 8, or half of 8, will give me 4. So I'm doing it the multiplying way, showing you the multiplying way. I could do the inverse of that and show you the division. 4 divided by 8 is 1/2. 8 divided by 8 is 1. 12 divided by 8 is 1.5. 16 divided by 8 is 2. I could do it that way. I did the multiply way. Is the number of ounces proportional to the number of cups? Yes. Because each time you're multiplying by the same thing. Cups times 8 every time equals the ounces. Each time you're multiplying by the same thing. How many ounces are there in 4 cups? Well, I can put that up here. 4 times 8 would be 32. I'm going to answer this question C up on the top up here. So 4 cups, 5 cups, and 8 cups. 5 times 8 would give me 40 ounces. 8 times 8 would give me 64 ounces. How do I know? Because I'm multiplying by the constant rate. Each time I'm multiplying by 8. That's how I know. So for any number of cups, oh, they're calling it X, how do we find the number of ounces Y? And the reason why we're using X and Y, a hint. Remember that coordinate axis that you had, and this was called X and this was called Y? Because we're going to graph these points eventually. So one of them goes on the x-axis. Wow, this is off. And one of them goes on the y-axis. So that's why they're calling them X and Y, just in case you were curious. For any number of cups X, how do we find the number of ounces Y? What would you say? You 3 people sitting here. What do you do?
Multiply by 8.
Well, I gotta hear you. Loud.
Multiply by 8.
Multiply by 8. Yeah. It's a sensitive mic. You have to kind of yell. In case you haven't noticed. Okay. I have some students helping me make today's video. Julie and Tyler and Emily. Okay. During Jose's physical education class today, students visited activity stations. Next to each station was a chart depicting how many calories, on average, by the way, would be burned by completing the activity. So they're giving me 2 variables. Time, how long you do it. Oh, for jumping rope. Oh, this is the jumping rope station. The longer you jump, the more calories you burn. Do you guys see what number to multiply by? This one's pretty easy. What'd you say? 11, Tyler, is correct. Times 11, times 11. Yeah, this one's easy. Each time you're multiplying by 11. So 0 times 11 is 0, 1 times 11 is 11, 2 times 11 is 22, 3 times 11 is 33, 4 times 11 is 44. This relationship was easy to see. Is the number of calories burned proportional to the time? Yes. Because, how do I know? every time or each time you multiply by 11. Use the time symbol. If you multiply your time times 11, you get your calories. So, in short, time times 11 equals calories. That rule worked every single time. If Jose jumped 6.5 minutes, how many calories would he expect to burn? So take my time, multiply it by 11. Do I get 71.5, Tyler?
Yes.
71.5. And what's the label, you guys?
Calories burned.
Calories. Or calories burned, I'm just going to say calories. Well, that was pretty easy. Next page. Well, the next bottom part of your page there. Example 3, you have a summer job. Alex spent summer helping out his family's business. He was hoping to earn enough money to buy a new $220 gaming system by the end of the summer. Halfway through the summer, after working for 4 weeks, because summer's usually 8 weeks, he had earned $112. Man, pretty good. Alex wonders, if I continue to work and earn money at this rate, will I have enough money? There's a key word there. Will I have enough money to buy the gaming system by the end of the summer? To check his assumption, he decided to make a table. Smart kid, this Alex. He entered his total money he earned at the end of week 1 and his total money that he earned at the end of week 4. Week 1, he earned $28. Well, week 0, he hadn't started. How much do you think he earned?
0.
0. Week 1, he earned $28. Is 4 times 28 112? That's what I would ask myself. Is 4 times 28 112? And Tyler says, he has the calculator.
Yes.
Yes! 4 times 28. 1 times 28. He's going to keep working at this rate. So they're telling me each week it's the same. So I kind of knew that these were going to work. At this rate, if he earns money at this rate, that means dollars per week. So what you're going to do is you're going to fill in the rest of this chart and answer. It says work with a partner. You can work on your own tonight. You're going to fill in this chart and answer A and B. And in tomorrow's class, we're going to go over it. Great job today, guys, for helping. Thanks.